Okay, for this lesson we're going to learn how to graph inequalities with two variables, so we'll be graphing inequalities on the coordinate plane. So the first graph that line we're going to graph is y is greater than or equal to 2x minus 3. So just like when we were graphing linear functions, the first thing that we're going to do is start with the y-intercept, which in this case is -3. So we'll plot our first point at -3 on the y-axis. And then our slope is 2 over 1, so we will rise 2 and run 1. So we'll rise 2, run 1, and I like to repeat that process a second time just so I get 3 points that fall in a nice line. So the new thing with inequalities is we no longer have an equal sign, so we're not going to just connect those dots and make a line and move on. We have to do a couple other things. So the first thing that we need to look at is our inequality symbol is a greater than symbol, and it's not equal to. So when we connect these points, we are going to connect them with a dotted line. After we've now connected them with a dotted line, or you can say a dashed line, because they're not equal to, so everything can go up to this line but not be equal to it. So that's called our boundary line. The next thing we need to look at is that y is greater than. So just like on the number line, we're going to shade one side of our line. So we're either going to shade this side of our line or we're going to shade on kind of the bottom right side of our line. So one way to do this is to test a point that's not on your line. So this line does not go through the origin. It's an easy point to test. So we would test 0, 0. So this would be my x-coordinate and my y-coordinate, and I would just plug them into my equation and evaluate and see if I have a true or false statement. When I do that, I get 0, first of all, is greater than 2 times 0 minus 3, and when I evaluate the right side of the inequality, I get -3. So 0 is greater than -3. This is a true statement. So that means that point is a solution for our graph, which means every point on this side of our line is a solution. So when we shade, we are going to shade everything on the top left of our graph, and hopefully you guys can do a better job shading than I am. So what this means is that every point on this side of our line will be a solution for this equation. But the points that are on the line, like this point of 1, -1, would not be a solution. And if you plugged in 1, -1 and tested it, you would see it was a false statement because it's not equal to. The other quick way to figure out which side to shade is your y-coordinate should be greater than the line. So if I go to any point on my line, the y-intercept's the easiest one to check, which is at -3, all the y values that are greater than -3 would be above. Or if I went to this point, all the y values that are greater than that point would be above. So I would shade above my line. Okay, so now we're going to look at another line that has a less than symbol now. So we're going to follow the same steps that we just did. The only thing that changed is the symbol is now a less than and then a greater than. So we're going to start at -3, and we're going to rise 2 and run 1. And I'm going to connect my points with a dashed line because it's not equal to that line. So this time, when I try to test a point that's not on my line, again, we can test the origin, 0, 0. This time, we should know that it doesn't work because it worked for greater than, so it shouldn't work for less than. But we'll test it anyways. So I plug it in, and I evaluate, and I get 0 is less than -3. And that is not true, so this is false. So that means this point is not a solution for our graph, and so that means none of the points on this side would be a solution. So that means we would have to shade the bottom right of our graph. And so all the points on this side of the line would be a solution for our equation. So that would be your answer when I asked you to graph that. That is what your graph will need to look like. So we'll look at a couple other graphs. So we're going to graph y is greater than or equal to -2x plus 3. We're going to start at 3. It's our y-intercept. And we're going to go down 2 over 1. So now This is the first time we've seen the equal to with our inequality. When I connect my dots this time, because the solution can be equal, I am going to connect it with a solid line, just like we did when we were graphing linear functions. And again, we can take a point not on the line. You can take, again, the origin, 0, 0. You can plug it into your formula. And this time we would get 0 is greater than or equal to 3, which is a false statement. So that means this side of the line where the origin is does not work for our solution. Or you can go and just think about the y coordinates should be greater than our line. So if I go to my line, doesn't matter what point I pick, the origin or the y-intercept's the easy one to pick. At 3, y values that are greater than 3 would be above the line. Or if I pick this point, y values that are greater would have to be above. So that means I should shade above my line. And so your graph for y is greater than or equal to negative 2x plus 3 would look like that. You would have to have the line and the shading. Okay, so we're going to graph y is less than or equal to negative 3. So we're going to start at 3. We're going to go down 2 over 1. I just wanted you to see another one that has a negative slope. And we're going to connect it with a solid line because we have the equal to. So if it has the equal to bar, solid line. No equal to bar, dashed line. So again, we can pick a point. We could pick the origin. Again, this time we get a true statement. 0 is less than or equal to 3. So that means we should shade this side of the line. Or the y coordinates should be less than the line. And so less than our line would have to be below any of these points. So I would shade below my line. And so any of these points and any point along that line are solutions for our equation. Okay, we'll graph a couple more. Okay, so let's graph y is less than or equal to negative 3/4 x plus 5. So we will start at 5, and we're going to go down 3 over 4. We should connect our line with a solid line for the equal to. And this time, we should shade, I'm just going to look at my equation. The y coordinate, y should be less than my line. So if I go over to my line, I'll start at 5. Less than 5 is below it. Or if I came over here at 2, positive 2, it's positive 2 up, so less than 2 up would have to be down. So I should shade the bottom left of my graph. Okay, the last one we're going to graph is 2x minus 3y is greater than 6. And just like with the linear functions, y has to be by itself in order to graph these inequalities. So we're going to solve for y. So the first thing that we should do is we should subtract 2x from both sides. So we're canceling 2x. When we do that, we get negative 3y is greater than 6 minus 2x. And now we're going to divide both sides by negative 3. And just like when we were solving linear functions and solving inequalities, I'm going to divide, and I'm going to get y. I'm going to divide all of this by negative 3 and get negative 2. And then the double negatives are going to give us a positive 2/3 x. And then don't forget the rule with inequalities. When you divide or multiply both sides by a negative number, your inequality symbol needs to change direction. So now this is just in a little bit of a different format, but we're used to seeing this. You should start at a negative 2. So we're going to plot our first point at -2, and then we will rise 2 and run 3. And again, I like to do 3 points. When I connect it this time, I am going to connect it with a dashed line or dotted line because it does not have the equal to bar. So there's my dashed line. And now the y value is less than, let me get rid of that. The y value is less than our line. So I'm going to go to my line, and everything that's less than my line needs to be below my line. So I'm going to shade everything that's below the line. And that is how you graph inequalities with two variables on the coordinate plane.